A hunt for merging dwarf galaxies has yielded an intriguing result 180 million light-years away, a galaxy very similar to the Milky Way, with two dwarf galaxy satellites just like our own Magellanic Clouds. A 9 feet by 5 feet view of NGC 2718 and its satellites imaged as part of the Sloan Digital Sky Survey. This system may be an analogue of the Milky Way and the Magellanic Clouds. Adapted from Padelson-Gupta 2017 unusual satellites, the large and small Magellanic Clouds, as observed from Earth. ESOS. Brunia. The large and small Magellanic Clouds LMC and SMC, the only bright and star-forming satellite galaxies around the Milky Way, have proven unusual in the universe. Satellite pairs of LMC-SMC mass are neither common in observation nor typically produced in numerical simulations of galaxy formation and evolution. Since the probability of having such an interacting pair of satellites in a massive halo is so low, this raises questions about how our system came about. Did the Magellanic Clouds form independently around the Milky Way and then interact? Were they more recently captured as an already merging pair of dwarf galaxies? Or is there some other explanation? If we could find other systems that look like the LMC-SMC Milky Way system, we might be able to learn more about pairs of dwarf galaxies and how they interact near the halos of large galaxies like the Milky Way. Conveniently, two researchers from Yonsei University in South Korea, Sanjaya Paudel and Chandrayasin Gupta, have now identified exactly such a system. An interacting pair, the UGC 4703 pair of dwarf galaxies show a stellar bridge connecting them, a sign of the past interaction when tidal forces stripped material from them as they passed each other. Adapted from Padelson-Gupta 2017 hunting for merging dwarf galaxies in various environments, Padelson-Gupta found UGC 4703, an interacting pair of dwarf galaxies that are located near the isolated spiral galaxy NGC 2718. This pair of satellites around the massive spiral bear a striking resemblance to the LMC-SMC system around the Milky Way. The authors performed a multi-wavelength study of the system using archival images from the Sloan Digital Sky Survey, the Galaxy Evolutionary Explorer spacecraft, and the Spitzer Space Telescope. They also gathered new observations of the HI gas distribution in the system using the Giant Meter Wave Radio Telescope in India. Padelson-Gupta find that NGC 2718 and the Milky Way have similar stellar masses, and the stellar mass ratio of the UGC 4703 interacting pair is around 51, similar to the mass ratio of the LMC to the SMC. The separation of the UGC 4703 pair is also roughly the same as that of the LMC and SMC, approximately 70,000 light-years. Similarities and differences. The HI gas distribution in UGC 4703 reveals both similarities and differences between this system and the LMC-SMC system. Padelson-Gupta 2017. The stellar bridge connecting the components of the UGC 4703 system are a sign of the past interaction, but a comparison of the optical and HI morphology between the UGC 4703 pair and the LMC-SMC pair suggests that the UGC 4703 galaxies are either interacting more slowly than the Magellanic Clouds, or that the interaction is at a more advanced stage than we see with the LMC-SMC. Understanding these similarities and differences between the LMC-SMC Milky Way system and this analog are an important first step to studying dwarf galaxy pairs as they interact near the massive halos of the large spiral hosts. In the future, further observations of UGC 4703 and detailed modeling of the system may help continue to puzzle out how our own Magellanic Clouds came about. Citation: Sanjay Paudel and C. Sen-Gupta 2017 APJL 849 L28 DOI 10.384720 for 18213 AA95 BF related journal article.